Today I am going to make a video on topic waves and oscillation. First of all, we will discuss water waves. Wave is a propagation of disturbance. Waves transfer energy from one point to another point. Wave is nothing but wiggle in space and time. Wiggle, wiggle in space and time. Now we will come to the classification of waves. There are three types of waves. Electromagnetic waves, sound waves, water waves. What is the link between waves and oscillation? Wave is a propagation of disturbance. Wave is a propagation of disturbance. Waves transfer energy from one point to another. Waves transfer energy from one point to another. Oscillation is a periodic movement of a particle or system which can produce waves. Oscillation is a periodic movement of particle which can produce waves. This is the link between waves and oscillation. Now we will discuss harmonic wave and how to represent graphically and mathematically. harmonic waves and how to represent it mathematically. And graphically. Harmonic waves are generated by harmonic oscillator. Harmonic waves are generated by harmonic oscillators. Acceleration is directly proportional to displacement and is negatively directed. Acceleration is directly proportional to displacement and is negatively directed. Corresponding waves are sinusoidal in nature. Sinusoidal in nature. Graphically, it can be shown by this. Two ways to represent a harmonic wave. Freeze A and plot amplitude versus T, and freeze T and plot amplitude versus X as shown here. Now mathematically it is represented way as mathematically it is represented as y is equal to a sine y is equal to a sine kx minus omega t. Y is equal to a cos kx minus omega t. Y is equal to a to the power a e to the power I kx minus omega t. Now we will move to the wave equation. This is the angle theta 2 and this is the angle theta 1. This small angle is the theta 2 and this is the theta 1. uh, this one is ft and this one is f1 and this one is f2 and this one is ft. We actually focus on a small segment of the vibrating string. M is equal to mass of the segment, mass of the mass of the small segment M is equal to mu del x, where mu is the linear mass density, mu is the linear mass density and del x is the small segment of the string. Length of the small segment of the string. F1 is the restoring force. Here F1 is the restoring force and F2 is the displacement force. Here F1 is the restoring force. Here F1 is the restoring force and F2 is the displacement force. Ignore the ignore the gravitational force. Now net force is equal to now theta is very small, so sin theta is equal to tan theta. For both angle theta 1 and theta 2. Tan theta 1 is equal to minus f1 by ft minus f1 by ft. Tan theta 1 is equal to minus f1 by ft and tan theta 2 is equal to f2 by ft. tan theta 2 is equal to f2 by ft. This is actually dy by dx. This is actually dy by dx x1, and this is actually dy by dx x2. Now net force is equal to f1 plus f2 is equal to ft dy by dx x2 minus dy by dx x1. This is equal to mu d2y by dt square as f is equal to ma. Now dy by dx x plus del x minus dy by dx x comma t by del x is equal to mu by ft d2y by dt square. This is equal to d2y by dx square is equal to mu by ft d2y by dt square. V square is equal to ft by mu. From here we can write that ft is equal to v square by mu. Ft is equal to v square by mu. From putting ft as v square by mu, we get d2y by dx square is equal to 1 by v square d2y by dt square. Now we will see the characteristic impedance of transverse vibration of a string. Characteristic impedance of transverse vibration of a string. It is actually Fy by Vy. We will prove this equation. A is equal to y is equal to a sin kx minus omega t. Fy is equal to minus ft sin theta. As theta is small, we can write ft tan theta. We can write the slope, tan theta means slope, we can write the slope as minus ft dy by dx. Vy is equal to dy by dt. Now dy by dx, from this dy by dx is equal to minus ak cos kx minus omega t. ak cos kx minus omega t, and dy by dt is equal to a minus a omega cos kx minus omega t. Now z is equal to fy by vy is equal to minus ft dy minus dx by dy by dt. Minus ft minus ft ak cos kx minus omega t by minus a omega cos kx minus omega t ft by k by omega ft by v is equal to ft by root over ft by v is equal to ft root over mu by ft is equal to root over mu ft is equal to root over v square mu square is equal to mu v. Z is equal to ft by v is equal to root over ft mu is equal to mu v. Thus the relationship is proved. Now we will discuss reflection and transmission at boundary. Reflection transmission of waves at boundary. This is incident wave, this is reflected wave, and this is transmitted wave. Now we will apply boundary conditions. Displacement must be continuous as at boundary. Wave at x is equal to 0, incident wave, wave at reflected wave is equal to transmitted wave. A1 plus B1 is equal to A2. Transverse force must be continuous at the boundary. Must be continuous. Ft d by dx yi plus yr is equal to Ft dy by dx t at x is equal to 0. Ft minus k1 minus k1 a1 ei omega t minus kx at x is equal to 0 plus Ft k1 b1 e to the power I omega t plus k1x at x is equal to 0 is equal to Ft minus k2 a2 e to the power I omega t minus k2x at x is equal to 0. Now minus k1 a1 ft plus k1 b1 ft is equal to minus k2 a2 ft a1 omega by v1 ft minus b1 omega by v1 ft plus is equal to a2 omega by v2 ft is equal to z1 a1 by a1 minus b1 is equal to z2 a2. Now I am going to discuss some questions on this chapter. A harmonic wave is described by the equation. A harmonic wave is described by the equation y is equal to 0.05 sine 4 pi x minus 2 pi t, where y is in meter, t is in seconds. Find the wave number, angular frequency, wavelength, period, and speed of wave. Here, comparing this equation with general equation y is equal to a sine kx minus omega t, we have k is equal to 4 pi and omega is equal to 2 pi. We know that k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k is equal to 2 pi by 4 pi is equal to half meter. We also know that omega is equal to 2 pi by t. T is equal to 2 pi by omega is equal to 2 pi, and omega is given 2 pi is equal to 1 seconds. Frequency is equal to lambda by t. Half by 1 is equal to half meter per second. The second problem is a string has a mass per unit length of mu is equal to 0.02 kg per meter and is under tension of T is equal to 50 Newton. Calculate the speed of the transverse. Calculate the speed of transverse wave on string. Mu is equal to root over T by mu is equal to root over 50 by 0.02 is equal to 50 meter per second. Thank you for watching this video.